Section 3.5 is on rational functions. Now, I do want to bring your attention to the class notes that are in Blackboard because I have a lot of information about finding asymptotes. And I want to review them with you just briefly before I get started on the homework assignments. In this example from the notes, we have examine the graph of f of x which is equal to 1 over x. Now you can make a table of values and plot the points, and you'll see that this is a rational function and it has a vertical asymptote. A vertical asymptote is a vertical line on the graph where the graph is going to get closer and closer and closer and closer to that vertical line as it approaches it from either the right side or the left side. You cannot put 0 into this function because you get a number over 0, which is undefined. This also has a horizontal asymptote. A horizontal asymptote means that the graph will tend to flatten out as you approach positive and negative infinity. Going to the right and left hand sides of the graph tends to flatten out. It has a horizontal asymptote. Now the way you find vertical asymptotes and horizontal asymptotes is to, well, first of all, vertical asymptote is a line x equals a, and the way you find the vertical asymptote is by setting the denominator equal to 0 and solving for x. Set the denominator of the rational function equal to 0 and solve for x. That will typically give you the equation of a vertical asymptote. To find horizontal asymptotes, you want to find, just look at the behavior of f of x as x gets large or small. Does this graph tend to flatten out? Now there are some equations that have oblique asymptotes, which we'll get to in a little bit. Now to the homework. The first one is to graph the following function. We can graph this by finding vertical and horizontal asymptotes. The vertical asymptote is found for vertical asymptote. I'm going to abbreviate this as VA. To find the VA, you set the denominator equal to 0. So if we set x minus 5 equal to 0 and solve this, we get x equals 5. That's a vertical asymptote. Now what you can do is graph a dotted vertical line at positive 5 on the x-axis. Now the graph should approach that dotted vertical line at x equals 5. It should get closer and closer to that line, but it shouldn't touch that line. So we can then make a table of values with x and y, and I would choose a couple points to the left and a couple points to the right. For example, I would choose maybe perhaps 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on, and get the corresponding y values out. Plug each of those into the function. For example, you plug in 0, you get 1 divided by negative 5. It's negative 1/5. Plug 1 in, you get negative 1/4. Plug 2 in, you get negative 1/3. Plug 3 in, you get negative 1/2. Plug 4 in, you get negative 1. Plug 5 in, you get an error. So the graph is going to look something like this on the left side. As when x is 0, there, I'll put this in there. It's negative 1/5, negative 1/4, negative 1/3, negative 1/2, and then negative 1. See how it looks like the graph is going down. Now if you get closer and closer to 5, say 4.5 and so on, this graph is going to continue to get closer and closer. And this also is going to tend to get closer and closer to 0 in this way. It's going to flatten out. Now you plug some numbers in on the right side of that vertical asymptote. Plug in 6 and you get positive 1. Plug in 7 and you get 1/2. Plug in 8, you get 1/3. So it looks like 6 positive 1, and then a half, and then a third, and then a fourth. It's going to continue to flatten out in this direction, and it's going to continue to get closer and closer to that vertical asymptote, actually without touching. So if you look at the choices here, it looks like choice C, where at positive 5 you see a break in the graph. At 5 on the x-axis you don't actually see the dotted vertical line here. I draw it when I do it by hand because it's kind of like a guideline. It's going to approach, it's going to get closer and closer. So I'm going to choose C for mine and continue on. So again, the way I graphed this was by finding the vertical asymptote and then graphing some points to the left and to the right. Let's look at number 2. Graph this function. Again, we can graph this by setting the denominator equal to 0 to find the vertical asymptote. Remember, I'll use VA for vertical asymptote. You're going to set the denominator equal to 0. If you set x minus 1 quantity squared equal to 0, take the square root of both sides and you get x minus 1 equals 0. Then you get x equals 1. What this means is you're going to have a dotted vertical line at positive 1 on the x-axis. The graph is going to get closer, but it won't touch that vertical line. So then you want to choose some points. For example, I would choose maybe a couple points to the left and a couple points to the right. Let's perhaps say -2, -1, 0. If you put 1 in, you're going to get an error. 2, 3, and 4. If you plug -2 into this function for x, you're going to get 1/9. Plug -1, you get 1/4. Plug 0 in, you get 1. Plug in 2, you get 1. Plug in 3, you get 1/4. And plug in 4, you get 1/9. Okay, we can plot those points. Let's use here. Plug in -2, you get a 9th. -1, you get a 4th. 0, 1. Now, if you continue to graph more and more points, you'll see that this graph is going to get closer to that dotted vertical line, and it's going to flatten out, looking in this direction. At plug in 2, you get 1. 3, you get a 4th. And you get 1/9 when you plug in 4. And plotting more and more points, you'll start to see that this graph also flattens out as you go to the right, and it becomes almost vertical as you approach x equals positive 1. So out of the choices, it does look like, for me, choice B. And you don't see that dotted vertical line. I always draw it when I do it by hand. And you'll probably need to do that in later math classes, so get in the habit of hand drawing those vertical asymptotes. Okay, let's now look at question number 3. Match the rational function with the appropriate description. The descriptions say we have a vertical asymptote at -7, the x-intercept is 7, the y-intercept is -6, and the vertical asymptote is 6. Well, the way you find the vertical asymptote, the VA, is you set denominator equal to 0. So if you set x plus 7 equal to 0 and you solve for x by subtracting 7 on both sides, you get x equals -7. This is your vertical asymptote. So we know choice A is correct. Fantastic. Now the x-intercept is not 7. The way you find the x-intercept, you set the whole thing equal to 0, and that's not going to give you 7 for x. It doesn't have a y-intercept at -6. The way you find the y-intercept is plug 0 in for x, and you get -6/7. And it doesn't have a vertical asymptote at 6. Alright, now in section question number 4, match the rational function with the appropriate description. Is there a hole in the graph at x equals 4? Does the graph have an oblique asymptote at y equals x minus 4? Is there a vertical asymptote at x equals 4 and horizontal asymptote at y equals 4? All right, the way we want to, again, find the vertical asymptote is to set the denominator equal to 0. However, we've got to watch out if there's any common factors. We want to reduce that first and then set the denominator equal to 0 to determine if there's any vertical asymptotes. The numerator can be factored to x minus 4 and x minus plus 4. And the denominator is x minus 4. We have a common factor in the numerator and the denominator. This can be simplified by dividing out, which leaves you with just x plus 4. However, what you need to be concerned with is where the denominator would equal 0. That would be at x equals 4. That would typically be where you have a vertical asymptote, but because it ends up being divided out with the numerator, we say this has a hole in the graph at x equals 4. And otherwise, if it couldn't be factored out, then you would have a vertical asymptote.